Welcome. As you well know, I'm pretty hot on Python for Grasshopper right now and Rhino. I'm taking a look at 130 scripts, going to go hard into a video series by Jake Hebbert, looking at the nature of code. I have to build on the shoulders of these giants. Fun little script to start. Just jump in here. I thought I had something floating around here, and now it's gone. Where the heck did it go? Anyway, there's something interesting for you to look at. I think it was this. Yeah, just spinning around. It's a walker with a variable pipe. I'm really not doing a lot of geometric, shenanigans and acrobatics. It's pretty simple stuff. It's a slow script, but I'll show you what it can do. It's kind of fun. So stop it spinning. We'll put it over to shaded and show you what's going on with that when I get to it. So let's put everything on, and we'll select everything to become viewable. And basically, I have a script. Actually, maybe not everything on. Let's just go here. This was the script I'm going to leave up for everything Python. I think it's a really good example of going in and taking a look at the Python script and realizing you import your maths, your Rhino script syntax, make a list, then just get into a range. And with that, I play with a little trigonometry, which I love so much. Make your points, add it, append it, and send it to output A. So you're going to see that constantly. Now Hebbert really does a great job in an early video. I should highlight. I've put it up that deals with lists that are lists of lists. So how do you extract that? And he's going to show you through a really cool Python node of setting A equal to X. And I think it'll be really cool if I do that video. Otherwise, this is in there every time. If you end up with some data and you want to start exporting and see it, instead of Rhino scripting it in the Python editor, you actually want to bring it into the node in the Grasshopper. It's always there. It'll be on every file from now on while I deal with Python. Enough said. Okay, so the first script here is what did I put on? I put on this walker, and it's the first one from Jake Hebbert's series. Please take a look at it. I think it came out in 2013. I could be a little wrong, but a nice example of a flat walking pattern that grows and has a seed. And as you go into it, you can seed it differently, and the walker moves around. It's pretty simple. It's got a time frame to how long you want to record it in steps, which is kind of nice. And so what he does is he imports Rhino syntax as RS. And I'm not sure why I have a little thing there. Time I had to use later. I did. I guess it just got typed in there. Randomness, you have to import as random as R, and then there's a function in there of seeding it. So get that prepared. The class is the first use of a class that has functions in it. So if you've not built a class, you want to do that. Class has to be named small c. Give it a name, put a colon, and then indentation's key for all the functions within it. You must have your initial self function declared, any variables you want to bring in by self x, self y. You can't just bring in x and y, but that's initializing that data at 0 and 0. The definition of the point is you're making a shape, which is going to add a point at those self x, self y, and then no z. So this is a flat, nothing's happening here, and you return a shape. And then your final function within there you can call upon is step, which will take a choice of a random integer between 0, 1, 2, and 3. And depending on what choice is made, your point's going to step north, south, east, west in these directions. And I've used the shortcut of x plus equals, so that's self.x equals self.x plus 1. And you can do the same for minus and plus. Then you've brought out w for walker, because that's going to be this walker class as you call upon it. And then a p list is the array, which I guess I could have put it up, or the list, I could have put it up earlier. And there's very simple to what you saw before. There's a bringing that in, appending that list, and putting that list to the output A. And there's a printing of lists just so we can see it in the output as well. And you get these points in there. I guess they're GUID objects. So really nice. And then I threw it through a line. You can see what happens. You can put through NURBS curves. You can put anything. Nothing too fancy there. I'm just copying script. Definitely credit going out to him, not me, Jake Hebbert. But then again, he's honoring Nature of Code, the book coming out of there, and he's running through hundreds of scripts to deal with nature of code. And I think I'll stay with this for a while as long as it touches on Python programming, I think, for the next 24 videos. That said, you're done. Do I want to save any changes? Yeah, because I changed that time value. Then let's go down here and see what I did here on this one. I thought, well, I'll just get in there before he does, and I'll play around. So this is a script I threw in there. And it's a script that all I really did was say, hey, I want to do something in the z-axis. So in doing so, I took the 0 that was in here after self x, self y, and I changed it to self times x, self x dot x times self dot y. And I thought that would be enough to do it. Bring it out, not much of a change, just minor little subtleties. Run that one, and then you can see your line. It's not too exciting, but it did jump into the Z direction there a little bit because my points are so small. And as I see that, you see that line kind of does some wild things. And I kept the count very low as 10 because I like building geometry. So I did a variable pipe geometry, and I've got this little wing dangler. And you can see how it changes slightly as I change the count. And then also I can really get some form-generated nonsense out of this just in a one little curve, which is based on a walker. So I think it's kind of fun to build yourself some awkward little printed forms that, you know, I think of this one artist. Oh, what is her name? She goes by Lumpy Pop. I think it's worth taking a Lumpy Plop. Lumpy Plop. And she came out of KCAI sculpture department, working out, I think, of Chicago. Anyway, I doubt she'll ever know I mentioned her and gave her credit in here, but boy, do I think of her artwork, Lumpy Plop, when I think of these things. Fun little objects, fun little sculptures, fun little monuments. And I'm always thinking of casting, so I like what happens in bronze. Now, what happened after that was I took his program, and he said, let's jazz it up in the Z direction. So he went in, gave it a huge count. I'm going to reduce the count a ridiculous amount. Edit, I'm going to bring that down to probably 100, and that's going to shrink it down to here. You can see I got a variable pipe on there. It takes a while to load, but there you go. You get a nice little sketch. That's what I was initially showing. So what did they do in here? Well, the main things that happened within the script was he changed the name, I believe. Well, he brought in self.x, self.y, self.z. He had to bring in and initialize that because he wants to go in z direction. He added, instead of self.x times self.y, he made that initialized variable within the class function in it and set that to self.z. And then he simply changed all this data down here, stepping 1 or 2 in that direction. He said, let's move it out of the random and put it into uniform so those points can go anywhere on here, which is really nice. And I brought in the Z component and then did the plus add tool that I talked about earlier. That's self.x equaling self.x plus step x. So he made these variables here within this function, step x with capital X, capital Y, capital Z. And you can change and pass any floats or any numbers to this now that you're dealing in uniform. And that makes for a really beautiful little script as we close it off and you dance through these steps. They take a little while, but if you're looking to get into some funk and make some really cool geometries, I've got some people online that are doing some wonderful architectural monumental works out of some of the scripts that I've been sharing, and they're getting off on their own and making some really cool creations. And that's what this open source for me is always about. And the front end people who can really do some nice finished work. I think it's Unreal Engine that they're working in. Please go right ahead. I'm staying pretty dead simple. I'm honoring other people that have been before me, and I'm going deeper. And, you know, I'm out of studio right now. I'll be back into it, and I imagine a lot of these scripts will be taken. But I'm on a Python Kick series for GHPYTHON nodes. If you haven't gotten into them, you're going to realize my scripts are getting a little more do-si-doed and crammed in here and filtered and all that wonderful stuff. I'll just keep moving right along. Thanks. 8-minute video.